Hello, I'm Wonjamun. In this presentation, I will introduce our new paper SlotCurri, which addresses the object over-fragmentation problem in video object-centric learning. The goal of video object-centric learning is to decompose visual scene into a small number of object representations. When given a video with spatio-temporal dimension, our goal is to compress the complex and redundant spatial dimension into object dimension. And since it decomposed the scene into object-centric representation, possible applications would be efficient video understanding, object editing in videos, and learning the object dynamics and latent space for feature state. Video slot attention framework is a typical approach to learn the video object representation. After extracting vision patch embeddings with pre-trained vision encoders such as Dino2, latent slot aggregate this visual semantics to form frame-wise slot representation. Then it is forced to reconstruct the visual embedding through the decoder, while the slot representation for the current frame is recurrently used for making slot representations for the next frame. In this framework, since slot must learn to reconstruct the visual embedding only with limited capacity, they naturally learn to gather similar semantics to maximize their coverage, forming object-centric representation. Regarding the problem statement, although the previous works have been enhancing the quality of scene decomposition, we found that the problem of object over-fragmentation remains a significant challenge. For example, given the video here, humans intuitively know that a car is a single entity. But when we tested this video with the previous state-of-the-art model, we found that they often split the object into multiple slots. And we found out that this issue starts from very beginning of the training iteration, since models try to fully use the slot capacity to minimize the reconstruction loss. So our motivation is that why not use small number of slot at the very beginning of the training and progressively add more slot. Therefore, we employ the curriculum learning using the number of slot as the curriculum variable. To go deeper into the method, SlotCurri is a multi-stage slot learning framework that starts with small slot budget to make the model first learn to group coarsely coherent regions. Then once the model converges into some point, we go through slot allocation phase that allocate new slot to the regions that has high reconstruction loss, because high reconstruction loss means that there could be multiple semantics. This makes the model to capture more fine-grained semantics that are underrepresented by the current slot, while preserving the regions with small reconstruction loss intact, addressing the object over fragmentation. To be specific, slot allocation consists of two main steps. First, in the slot assignment stage, we compute the reconstruction loss for each region covered by each slot. Then we normalize these errors using a softmax to determine how many additional slots each region requires. Next, in the slot expansion stage, we generate new slot based on the assigned number for each parent slot. Each new slot is created by perturbing each parent slot with Gaussian noise, where the scale of noise is controlled by the distance to the nearest neighboring slot, ensuring that the child slot stays within the target region. Next, I will describe the training objective. The typical objective to train video object-centric model is MSD reconstruction loss, which often blurs the spatial details. However, we found that this is critical in curriculum learning where the semantic boundary of previous curriculum is inherited to the next curriculum stage. Take this figure for instance. Using MSE often result in ambiguous semantic boundary. So you will notice a portion of the person is misclassified into a different semantic, and this error is directly propagated into the next curriculum stage. Therefore, without that, preserving the structure information is really important. So we additionally employ the SSIM objective to penalize the structure difference to form the precise semantic boundaries from the early training stages. And consequently, we could mitigate the problem of error propagation throughout the curriculum. And lastly, although our SlotCurri effectively addresses over-fragmentation issue, we find that earlier frames are often still underfitted to each scene since they lack the contextual information within the video. Therefore, we employed cyclic inference strategy so that earlier frames can also benefit from accumulated contextual information. And since the cost of slot attention is negligible compared to feature extracting phase, only the minimal runtime overhead is introduced. For the experiment, we evaluated our method on YouTube video instance segmentation dataset along with two synthetic movie datasets. Foreground ARI and MBO are used for the evaluation metrics, and I want to notify that foreground ARI is more relevant metric to object over-fragmentation as it measures the clustering performance, telling whether each ground truth object is grouped by a single slot or not. Also, for the component ablation study, we have compared our Reconstruction-Guided Curriculum Learning (RG) to its naive counterpart, which simply adds up the randomly initialized slot latent. And on the right side, we have introduced a new metric to measure the degree of overfragmentation. So the value here indicates the average number of slots to represent each ground truth object. In addition, SlotCurri has many advantages over previous methods. First, we found that SlotCurri is robust to varying the number of slot capacity, and the object-centric representation of SlotCurri is actually beneficial in predicting the future object state. For the qualitative results, we compared our work with the previous state-of-the-art model, and while the previous method struggled to perceive human as a single object and failed to distinguish different people, we found that SlotCurri effectively addresses these limitations. And you can find more qualitative results in the paper. Finally, we recognize two key limitations in SlotCurri. First, although SlotCurri is able to distinguish the small objects, we find that the slot coverage often extends beyond the actual object boundaries for small objects. Second, the model still struggles with occluded or overlapping objects where clear separation remains a challenge. And I'm currently working on these limitations, and I'd love to have any opportunities to discuss on future directions. Thank you.